Motion problems, winds and currents. These kinds of situations show up often enough that we're just going to introduce both of them here and do one example. So currents, in our first example, we're looking at a boat, and there's some sort of hypothetical still water speed that we're going to refer to as S. So S is the still water speed of the boat, meaning the speed that the boat would hypothetically be going if there were no current. C is the current speed, or the speed of the current. So what happens is, if the current is going this direction and the boat is going this direction, then we're going to add the still water speed to the current speed. The boat's going to go faster. If the boat is going against the current, it's of course going to go slower, and we would take the still water speed and subtract the current speed to get the actual speed of the boat. So this is the actual speed of the boat. The same thing happens with airplanes and wind. So if we now let S be the still air speed of the plane, that's the hypothetical speed that that plane would be going in still air, and we're going to use W for the wind speed. We see the same kind of situation going here, which is that if the wind is going this direction and we're going with the wind, then we add the still air speed to the wind speed, and if we're going against the wind, then we subtract the wind speed from the still air speed to get the actual speed of the plane. So, to see how this gets applied, let's look at an application. A cross-country flight traveling with the wind covers 3,000 miles in 5 hours. So with the wind, 3,000 is our distance, and 5 is our time. The same plane then changes direction and travels to Texas against the wind, covering 1,500 miles, 1,500 being our distance, in 3 hours, 3 being our time. We're asked what are the wind speed and the speed of the plane in still air. So using the variable definition that we just explained above, we're going to have W as our wind speed and S as the still air speed of the plane. When we're going with the wind, we go S plus W for our actual speed. And when we go against the wind, we go S minus W for our actual speed. To set up my equations, I'm going to use the relationship distance equals rate times time, so that I get from my with the wind row a distance of 3,000 equals a rate of S plus W in parentheses, because the whole rate needs to get multiplied by the time, times a time of 5. And then looking at my against the wind row, I'm going to get distance of 1,500 equals rate of S minus W, again in parentheses, times a time of 3. So this is my system of equations. Rather than distribute the 5 into the parentheses, since I see that 3,000 is a multiple of 5, it's going to be a little bit easier in this case to just divide both sides by 5 from the beginning to get 3,000 divided by 5, which is 600, equals S plus W. And same thing with the second equation, because 1,500 is a multiple of 3, I'm going to choose to divide both sides by 3, getting me 1,500 divided by 3, which is 500, equals S minus W. I wouldn't do this if the number on the left-hand side were not a multiple, because it would introduce some fractions, which then, if we wanted to clear fractions, we would end up undoing it in the very next step anyway. So I only do this if it's going to work out nicely. Now I'm going to solve this using the elimination method, since W is already set up to drop out here. So when I add the two equations together, I get 600 plus 500 equals 1,100, and S plus S is 2S, and the W's dropped out. Dividing both sides by 2 gets me S equals 550. Now I do need to come back to one of these original equations. I can take the first one, 600 equals S, which is 550, plus W. That 550, of course, came from this S here. Now, subtracting 550 from both sides gets me 50 equals W. So these are my two answers, but I still need to express them with labels and units. As I defined above, S is the still airspeed of the plane and W is the wind speed. The units here are all miles per hour because our distance is measured in miles and our time is measured in hours. So the still airspeed of the plane is 550 miles per hour, and the wind speed is 50 miles per hour. So that I've answered for my final answer with numbers, labels, and units.